Okay, before we start, let me just give you a brief on which chapter we are doing right now. Today is chemistry, Form 4 chemistry, which is equivalent to Year 10 chemistry. And I started with chapter 2 because chapter 1 is not much content to be studied because chapter 1 is like an introduction to chemistry for Form 4. So chapter 2 is matter and atomic structure. I've been using this learning method, the brain drawer learning method, as I call it, step 1 until step 10, mainly on physics. This chapter is the first chapter that I'm going to try to experiment on chemistry. Let's see whether it works. How do we define whether it works? Is by the end of the lesson at step 10, if everyone can get a good result from the MCQ. If yes, then it works, right? So let's get ready. Let's start. Okay, let's start now. Okay, Xuan joined just in time. Morning, Xuan. Morning, Xingling. Right. So I just briefed the student who came earlier just now before Xuan that we are going to start experimenting on chemistry. We have been doing it for physics, and we have been doing it with GCSE. That means a lower level for the secondary school on physics and chemistry and also biology. It works. So now we are trying to experiment on a higher level for Form 4 chemistry, chapter 2. I did not choose chapter 1 because chapter 1 is an introduction chapter for chemistry. There's not much content to learn that is important, I think. So we started with chapter 2, matter and atomic structure, right? The name itself is telling you it's related to the atoms, the arrangement of the atom, the structure of the atoms, the proton, nucleon, and also electrons. Right, we'll go into all the details as we go along. Right, so same method. We are going to have 2 hours, about 2 hours, and following step 1 until step 10. So let's start with step 1. We have 4 drawers, and they are matter, atomic model, atomic structure, and isotope. So how do we remember this drawer in sequence? As usual, we are going to have the main story, right? So Matt, atom bomb. Mongolia super twin on iStop. Right. So there's a guy called Matt, or Matthew, short name for Matt, has an atom bomb. So you can imagine a guy that is holding an atom bomb. Then you have this Mongolia super twin. There's a twin baby. So you can imagine as a twin baby or twin kids. They are from Mongolia. They are on the iStop. Right. So Matt is linked to matter. Atom bomb is linked to atomic. Atomic, okay. Mongolia super is linked to model and structure, right? So Mongolia is linked to model and structure. Sorry, Mongolia super twin is linked to model and structure. So there's an atomic structure, there's an atomic model. Then isotope sounds like isotopes, right? So Matt has an atom bomb, and then there is this super twin from Mongolia. It's on the iStop. I'm going to show you the video. Okay, let me just open the video.
Form for Chapter 2, Matter and Atomic Structure.
Okay, if you cannot see and cannot hear, let me know. Let's start.
Form for Chapter 2. Matter and atomic structure. Matt has atom bomb. Mongolia supertwin on ice top.
Okay.
Draw 1.
If you have a problem on the video, let me know. If not, then we will move on. Right. So Matt has atom bomb, Mongolia super twin on ice top. The animation of, I don't know, maybe 10 seconds or 20 seconds, hopefully will help you to remember the drawer name in sequence: matter, atomic model, atomic structure, and isotopes. So now we have we move to drawer step 2. Okay, what time did we start? 8:34 a.m. Okay, so let's move to step 2. We have also divided into 4 different drawers. So drawer 1, you see here. Then you have drawer 2, which you see part of it. Then continue with drawer 3 here. And you have drawer 4. And that's it. Right. This chapter we have only 4 drawers. Most of the chapter we have 5 drawers, but this chapter we have 4 drawers. So we will take 2 minutes to read drawer 1 until drawer 2. But let's set the right expectation. Do not expect yourself to fully understand everything when you read this step 2, because we are still in step 2. So you need to pick up the key information about that drawer. Right? Let me just reconfigure it back. So drawer 1, you have 1 and 2 key points, and each key points you have a few smaller points that is inside the key points. Okay. Then you have drawer 2. You also have 2 key points: the scientists and also the atomic particles. Right. So 2 minutes starts now. You should be in drawer 2 by now. If you finish reading, you can read it again if you want. Twenty seconds. Ten seconds. All right. So we have read drawer 1 and drawer 2. Drawer 1 is the matter, and drawer 2 is the atomic model. Right. Drawer 1 and drawer 2. So in total, we have 4 drawers. And we are in step 2 right now. Step 1 is this one. If you want to just copy it quickly, you can copy it. I will continue on the step 2. We are in drawer 1 and drawer 2. So there are a few key important points that you need to know on drawer 2, scientists and particles, right? As I always say, do not worry that if you do not understand fully, that is fine, because you are in drawer step 2. Understanding level should be, we are expecting it to be at 2. 2 means out of 10 questions, if I give you the MCQ, you should have minimum 2 answer correct. Shen, your camera is on if you not realize. Okay. Yep. So that is the drawer 1 and drawer 2. Let's continue to go on drawer 3 and drawer 4. All right. We'll do 2 minutes as well. Let's start now. Atomic structure and isotopes. Isotope, ice on top. Okay, you should be reading drawer 4 by now. Twenty seconds. All right. Drawer 3 and drawer 4 is relatively a bit harder than 1 and 2 because you have new concept over here. You have proton, you have nucleon, then you have this Z number and A number, right? Then also you need to know about cation and anion. And there's this shell that if it is new to you, maybe it's something that you never heard before. And valence electrons, right? That's why it feels more difficult than the previous 2 chapters, 2 drawers, which is fine. You're going to know what exactly is this as we progress to step 3, 4, 5, and so on. Then for the isotope, maybe this formula scare you a bit, but this is not something very difficult. This is just a relative atomic mass. You know in more detail later is how do you weigh the mass of an atom. You know, atom is so small. How are you going to weigh it? It's not like a bag of rice that you can weigh it for 15 kilogram easily, or your weight, let's say, is 40 kilogram or 50 or 80 kilogram, right? But atom, how do you weigh atom? The mass of atom, we'll know it later, right? So let's go to step 3 for drawer 1. And the expectation is to have you to increase your understanding level from level 2 to level 3. Level 3 is still relatively a low level because out of 10, we're expecting you to get only 3 questions correct. Okay, so let's do 2 minutes, and I'm going to scroll down as we go along reading it. Okay, on the right is the reference, which is this part. Okay, on the left is the step 3, which you need to read for 2 minutes. Draw 1. Let's start now. Okay, I'll scroll down a bit. So you should be in the table right now. Don't worry too much about the formula of this substance or this molecule, C10H8. It's just an example. Okay, let's move on to drawer 2. Drawer 2 is quite simple. We'll do 1.5 minutes. Let's start now. If you worry about memorizing the name, don't worry. We'll have a story for it to help you to remember the name easier. You should be in point 2 now. If you finish reading, you want to read it again, please do so. Okay. We'll try to go a bit faster this round and without rest. There's no 5 minutes rest, just for information. Okay, for this drawer 3, we'll do also 1 minute and 30 minutes, 1 minute and 30 seconds. Let's start now. You should be in point 2 or point 3 now. Okay, for those who cannot imagine what is this yet, don't worry, you just need to know there is this proton number, nuclear number, A and Z. Then you need to know there is this positively charged and negatively charged ions, right? So proton, nucleon, two things. And then ions, you have positive and negative, which we call it anion and cation. And then you have these valence electrons. what is this valence electron? Is this located at the outermost shell? If you don't understand what is this yet, don't worry. You just need to know that there is something related to shell, and there are few layers, 1 layer, 2 layers, 3 layers, and the valence electron is the outermost layer or outermost shell. All right. And this AZX is how you represent the particular substance. All right. So that is drawer 3. Let's go to drawer 4. Let's see how long is this. Okay, let's do 1.5 minutes also. Start now. Okay, you should be in 4.2. Don't try to remember the name of the isotopes. Don't try to memorize. Just need to know that there is different isotopes for different usage in different field. Right, 10 more seconds. All right, that is step 3. So I hope, okay, let's read this step 2 again quickly. And I need you to feel that you understood a bit more compared to the first time you read step 2, right? So let's do 2 minutes. I'll scroll down from drawer 1 until drawer 4. Let's start now. Drawer 1 until drawer 2 for 1 minute, then 3, 4 for another minute. Right. I want you to feel that now you read this, you understand more. Not to the expert level, but you understand more compared to 10 minutes ago. Right? You should be in drawer 2 now. You should be in drawer 3 by now. Okay, you should be in drawer 3 or 4 by now. Twenty more seconds. Okay. So, yep. The expectation is you need to feel that you know a bit more than 10 minutes ago, and that's it. We are not expecting you to be an expert right now, but as long as there's a progress, there's improvement. So now let's go to step 4. Step 4 is to set you to increase from level 3 of your understanding to level 4. Just one level up. Just one level up. Not level 10 yet, not level 9 yet, but one level up. Right. So let's do this. Frequent asked questions. We will do drawer 1 until, let's see. Okay. Drawer 1 here until the conditions, different condition, the entire, the question number 1. We will do, let's do 2 minutes. Let's start slowly a bit. Okay, for the question 1. Okay, 30 seconds. Ten more seconds. This should increase your level from 3 to 3.5 for drawer 1. All right, drawer 1 is matter. Remember, matter. Math has an atom bomb. So math. Now let's increase from the 0.5 to 4. And we will do question 2 for 1 minute and 30 seconds. 90 seconds. Question 2. If you want to read question 1 again, I left a few, some part of the question 1 here. Twenty more seconds. Maybe this part sounds familiar for Singling. Okay. Time's up. Okay, just for Singling. This one sounds familiar, right? This is the latent heat that we learned just now on the first class. Latent heat. All right. Drawer 2. Let's go to drawer 2. Drawer 2, we have atomic model, right? We have matter as drawer 1. We have drawer 2 as atomic model. So let's increase the level from level 3 to level 4 for drawer 2. For drawer 2, let's do 2 minutes for 2 questions. 2 minutes for 2 questions. I hope it's not too fast. Okay, let's do 1.5 minutes for one question. Right, let's not rush. 1.5 minute for one question. Let's do this. Right, question 3. If you are done question 3, you want to start with question 4, you can do it. I'll give you 1.5 minutes later for question 4 as well. 30 seconds for question 3. All right, another 90 seconds for question 4. Then we complete drawer 2. Twenty more seconds. Okay. To the scientists, if you want to understand it in a very concise way, this is how I understand it. Dalton discovered the matter made of atoms. Thomson discovered the electrons. Rutherford discovered the nucleus. Bohr discovered the electron move in shells. Right? So let's go to drawer 3. Drawer 3. Drawer 3. Okay, same thing. Let's do 90 seconds for one questions. Let's start now. Drawer 3. 15 seconds. By now, you should know a bit more what is proton number and nuclear number, and cation and anion. Okay? Let's move on to question 6. Same drill, it's 90 seconds. I intentionally put question 5 above in case you want to read it again. Thirty seconds. Ten seconds. Okay, time's up. All right, so your drawer 3 should improve to level 4 now. Let's go to the last drawer. There are 2 questions in 1 page. We will do 3 minutes. Let's start now. 3 minutes for the 2 questions. Isotope, what is isotope? Okay, 1 more minute. If you finish reading, you want to read it again, please do so. You have 1 more minute. 20 seconds. All right. If you are wondering what is periodic table, it's a table that is having the elements with the atomic mass, and also, yeah, it's a big table. You're gonna learn this in this Form 4, chapter, if I remember correctly, is chapter 4. Now you're in chapter 2. You're gonna learn what is periodic table in more detail in chapter 4. Right? So now we have completed step 4. Right. So I hope, let's do this. Let's not hope. Let's try to read this again. What time did we start just now? 8:34. Now is about 40 minutes. Right, 40 minutes later, and you read this again, you should feel that you are able to understand much more compared to uh, 30 minutes. Okay, let's do 2 minutes to read drawer 1 until drawer 2 for first minute, then drawer 3, drawer 4 for the second minute. Let's do drawer 1 now. You should have this feeling. You learn more. You understand more compared to 30 minutes ago. Okay, you should be in drawer 2 by now. Okay, you should be in drawer 2 or 3 by now. Okay, you should be in drawer 3 or 4 by now. You should feel that you understand more compared to 30 minutes ago. Ten more seconds. Understand more doesn't mean that you are expert, because we are still in step 4. Right? Let's move to step 5. Okay. I think we are fast today. These sessions, in less than 1 hour, we are already in step 5. Okay, let's do the same drill. Let's do the same drill. Drawer 1 starts now. 2 minutes. I'm going to slow down as we move. Okay, you can read drawer 1 now. Drawer 1 here. Should be in point 2 by now. You should be in point 2 or 3 by now. You should be in point 4, 3 or 4 by now. Should be 4 actually. Okay, that is step 5. So for drawer 3, drawer 1, drawer 2 is atomic model. Let me see how far is this. Okay. Okay, let's do 1.5 minutes for drawer 2. Let's start now. Atomic model. Okay, let me scroll down a bit. It should be 0.2 by now. Should be 0.2 or 3. All right, that is drawer 2, step 5. So your understanding level should be at level 5 for your drawer 2 and drawer 1. Drawer 3, let's see how long is this? Okay. So we will take 2 minutes. Atomic structure, all right? Atomic structure. Let's start now. Atomic structure. It should be 0.1 or 0.2. Okay, it should be 0.2 or 0.3. It should be 0.3 or 0.4 now. I think now it makes more sense. Ten more seconds. I hope it's not too fast. It's definitely faster than normal compared to the previous class, because we are almost completing draw step 5 in less than 1 hour. All right. Okay, let's see. Okay, let's do 2 minutes. 2 minutes total, we have 4 points. All right, let's start now. you should be 0.1 or 0.2 now. Okay, I think it should be in 0.2 or 0.3 now. Okay, it should be 3 or 4 now. If it is too fast, let me know. Just message me. Ten more seconds. Okay, now we have completed step 5. Let's throw this back to step 1, draw 1. So I hope you guys are able to remember now the name of the drawer in sequence: matter, atomic model, atomic structure, and isotope. Right, this is the one. And how do you remember this easily? Matt has an atomic bomb, and then there is Magnolia super twin on isotope. Right, so Matt is matter, atomic is atom, Mongolia, so not Magnolia. Mongolia is a model, super is structure, isotope is isotope. Sounds like isotope, right? Isotope. Now, I created this story. You can create your own story because this story, the objective of creating the story is to make something emotional and silly so that you can remember it better. Remember our formula: if information plus emotion equivalent to long-term memory. Information plus emotion equivalent to long-term memory. So I have information, so much information over here. I need to add in emotions. That means I convert it into a silly story, and then hopefully that it will help me to form a long-term memory. Let's see. Solid LG phone. I think you have, there are different type of phones. You have Nokia phones, you have iPhones, you have Samsung phone. There's one brand called LG from Korea, right? Solid LG phone, breathe in heat and breathe in heat and breathe out heat, right? Then melting and freezing later. So what does it mean? Solid LG phone is talking about the matters. You have solid, liquid as L, G as gas, then you have plasma as phone. So solid LG phone. Breathe in heat and breathe out heat. Okay, for human, we breathe in oxygen and breathe out carbon dioxide. But for this LG phone, it's able to breathe. Okay, it's not a living thing, but for my story, it's able to breathe. Breathe in heat, so absorb heat, and release heat. Right. So obviously, I will not be able to fill up all these key points into my story. If I do, then the story will be a very long story. But it's to help you to remember, there's something related to absorb heat. There's something related to release heat, okay, which is the different state, right? Then melting and freezing later, right? So I took melting and freezing as the first, this is a change of state, so that you will be able to know that which one is in heat, absorb heat, melting is absorb heat, freezing is release heat, okay? And also melting and freezing is to also reflect this melting and freezing point on this point number 2, right, for drawer 1. Okay. So another way to remember this easier is when the heat is absorbed. Okay, if you divided them into solid, liquid, and gas, solid is the lowest level, gas is the highest level, liquid is the middle level. Absorbed heat means you are going from lower level to higher level, so solid to liquid, or liquid to gas, or solid to gas. So from down to up, you need to absorb heat, right? Because it's harder to climb the staircase, so you need to eat more rice, right? So you need to absorb heat, absorb more energy, for example. Okay, if you want to, if this can help you to not to be confused about which state is in absorb, which state is in release, right? For the release is the other way, from up to down, gas to liquid, liquid to solid, or gas to liquid, right? So that is drawer number 1. Drawer number 2 is, okay, remember I told you, don't worry about memorizing the scientist name. I'll help you in this story. Don't touch red button on atom. Okay, don't touch red button. This is the Dalton Thomas Rutherford ball. Don't touch red button. Okay, so imagine there's this red button in front of you, don't touch. Then you have atom, nucleon, atom, electron, nucleus, then they are running, right? So atom is reflecting something related to Dalton, right? So then electron is to reflect on something related to the discovery of Thomas. So this atom is number 1, electron is number 2, nucleus is number 3, run is number 4. Also, you have this scientist, D number 1, T number 2, red number 3, button number 4. So if you see, Dalton is about atom, Thomson is about electron, Rutherford is about nucleus, and then Bohr is about some movement. So I make it as run. Okay, don't touch red button on atom, electron, and nucleus, run. Okay, because the red button, if anyone touch, then it's going to be exploding. It's so better to run away, right? So I hope that makes sense. Of course, that story doesn't make sense, but I hope it makes sense in terms of helping you to be able to remember the story better with these emotions. Z drive for draw number 3, atomic structure. Z drives Proton. Ali drives Nissan. Kathy is happy. Arnold is sad. Okay, so what does it mean? Z drive Proton. So you have a friend called Z. Okay, Z is the Z. And he drives a Proton car. You know, Proton is a car made in Malaysia. For the student who live in Malaysia, I'm sure he or she knows. For the guys who doesn't live in Malaysia, there's a car. There is a Malaysia car, the brand is Proton. Just like you have Toyota, you have Nissan, you have BMW, Mercedes, right? You have Proton in Malaysia. Okay, so Z drive Proton. So Z is representing Proton. Ali drive Nissan. A represent nucleon, N for Nissan, right? So Kathy is happy, Arnold is sad. Kathy, this girl is super happy. This boy, Arnold, is super sad. Why? Because cation, when it loses electron is negative. So cation is something is positive. It's a positive ion. So cation represents Kathy. Anion is Arnold. So Arnold or anion gains electrons, then the ion become negative ion, negatively charged ion. Okay, so that's how I remember this. Right, I didn't put this shell here in the story, but I hope once we remember Kathy and Arnold, we remember there's one more, which is electron arrangement, shell. Right. Okay. You can add another shell story if you want, right? But I just did not add it here. If you want, you can add maybe somebody is playing this shell, shell as in you see it from the sea, from the beach. Okay, isotopes. Isotope is draw number 4, right? Draw number 4, you have same proton car, but different neon light. Go on a ramp, right? So, oh yes, this is the drawing. For draw 1, 2, 3, these are the story for the drawing. The drawing for the story. So for drawer 4, you have two same proton car, proton and proton, but different neon light. This is so much brighter. This is not so much. Maybe it's another color, as long as it's different. And they are going on a ramp. Why this story? Same proton number. Isotope is same proton number, but different neutron number. Okay, different neutron number, right? And this is going to help you to remember same chemical properties, but different physical properties. Masses, different masses mean different physical properties. Then why RAM? RAM, see, relative atomic mass, right? Because car go on a ramp, RAMP, right? Go on a ramp. So it's helping you to remember there's something that you need to know about relative atomic mass, RAM. Okay, so that is the story. Let's watch the story. Okay, I'll start from beginning. It's only 1 minute. Okay, there is the main story. Let's start now.
Form for Chapter 2, Matter and Atomic Structure. Matt has atom bomb. Mongolia's supertwin on ice top. Draw 1. Matter. Solid LG phone, breathe in heat. And breathe out heat. Melting, freezing later. Draw 2. Atomic model. Don't touch red button on atom. Electron and nucleus. Run. Draw 3. Atomic structure. Zach drive proton. Ollie drives Nissan. Kathy is happy. Arnold is sad. Draw 4. Isotopes. Have same proton car, but different neon light. Go on a ramp.
Okay, I hope this funny story was going to help you to remember the story. And I hope by now you know why these stories are important. I'll send it here, the link. Okay, I hope you understand this now. Why these stories are important is to help you to remember some of the key information or concepts in each drawer, right? So whenever anyone asks you, can you explain to me what is atomic structure? Then you start to think about the Zach drive proton, Ali drive Nissan. Okay, the story just now, right? The two proton was racing, and then the proton car suddenly become Nissan, and then there's this girl was happy, and his either his boyfriend or the boy is sad, right? So this give you some information that you'll be able to explain to whoever who asks you this question. Tell me what do you know about atomic structure. You can write about this standard representation Z and also the N, the A, Ali and Z. Then what is Z represent? What is A representing? Right. Then you can also talk about this cation and anion on the ion side. Right. Then you can also talk about the electron arrangement. Okay. So I hope that makes sense. Now, having that as a reference, let's do step 7. How do we do step 7? I did not put the drawer's name. Okay, I should name the drawer. Okay. Anyway, how do we do this? Read the questions, form your own answer, then read the answer, and see whether there's any new discovery. All right. So let's do 1 and 2 in 2 minutes. Where's my clock? Yeah. Let's do now. Meanwhile, I'll write the drawer. Drawer 1, matter. Okay, this is also drawer 1. This is the latent heat. Okay, 1 and 2, if you want to continue 3 and 4, you can do it. If not, just focus on 1 and 2. I'm going to give you more time for 3 and 4. What is plasma? This drawer. Okay. Okay, drawer 2. Okay, describe the role. Drawer 2. Okay, calculate this. This looks like drawer 3. Okay, 20 more seconds before we move down to question 3 and question 4. Ten more seconds. Okay, 3 and 4. 2 minutes starts now. Valence is a okay. I think it's too long, right? The time's given. Let's continue. 5, 6, 5, 6, 7. 5, 6, 7. Then 8, 9, 10. Okay, 5, 6, 7, 2 minutes. Okay, do not need to answer drawer question 8 if you are at question 8, because the question is incomplete. You can skip question 8 if you are in question 8. 30 more seconds for question 5, 6, and 7. Ten more seconds. Okay, let's do 1 minute for 9 and 10. 9 and 10. 8, no need. 8, question is incomplete. Okay, 30 more minutes. Sorry, 30 more seconds. Five more seconds. All right. So by now, you should understand much more at the level of 7. And there are 4 drawers. And the name of the 4 drawers, you should know it by now. And what are the key points inside each of the drawers? You should also roughly have some ideas, right? On the drawer 1, those are the key points. With the story even, we have the story just now. You can watch it again if that story helps you to remember the information inside each drawer. Then drawer 2, you have the scientists and the subatomic particles. Drawer 3, you have these 3 important points: the Z, the A, the ion, and the electron arrangement. Then isotopes. Isotope is the same P, proton, and different neutron, different neon light, remember? Same proton car, but different neon lights. Okay. And on the RAM, so there's this relative atomic mass that you need to know as this. Now, we are moving to step 8. Right, I think step 8 is the easiest. You just need to watch for about 7 minutes or 8 minutes.
Welcome to this explainer.
Okay,
Today
let's
we're
stop
going
here
to
first. Okay, whoever who cannot have problem with the video, let me know. I will start now. 8 minutes. Let's focus on the 4 drawers. Let's start now.
Welcome to this explainer. Today we're going to embark on this wild journey, zooming all the way from the physical world we can actually touch, right down to the invisible subatomic engines that literally drive the entire universe. I mean, have you ever stopped to wonder how the solid ground beneath your feet and, say, the life-saving machines in modern hospitals are ultimately governed by the exact same microscopic rules? Well, today we're going to unlock those rules together. Let's get into it. Real quick, here's our roadmap for this explainer. We'll start with the visible world, then take a historical zoom, dive into the microscopic engine, and wrap up with real-world power.
Okay, part 1, the visible world, matter and states. Let's kick things off by challenging some basic assumptions. Think about a huge, beautiful rainbow stretching across the sky after a storm. It's visible, it's right there, right? But what's its mass? What's its volume? The answer is, it doesn't have either. Because a rainbow lacks mass and volume, it isn't actually matter at all. It's just light, an optical illusion. And thinking about this forces us to get really strict about how we define the actual physical stuff making up our universe.
So, to set the ground rules here, for something to be considered matter, it absolutely must have mass and take up space, existing primarily as a solid, a liquid. And here is the crucial takeaway that really sets the stage for our whole explainer. Matter isn't just one big continuous blob. It actually consists of particles that are incredibly tiny and entirely discrete.
So, what makes a solid or a gas a gas? It all comes down to 3 things: kinetic energy, particle arrangement, and attraction forces. In a solid state, particles are packed tightly together. They've got low kinetic energy and strong attraction forces holding them in place. But you add some heat energy and they loosen up into a liquid. Still pretty close together, but now they have enough kinetic energy to move around. Add even more energy, and boom, those particles break far apart into a gas. The kinetic energy goes way up, and those attraction forces become incredibly weak. You actually see this push and pull of heat energy changing states all the time in your daily life. Think about a scoop of ice cream on a warm day. It's absorbing heat from the room, right? That heat ramps up the kinetic energy of its particles, forcing it from a solid into a liquid state. Or look at the exact opposite. Water vapor in the air hitting a freezing cold glass window. The vapor loses heat energy, slows down, and condenses into solid little liquid water droplets. It's all about thermal energy transfer. Now here's a really fascinating point about a substance's thermal properties. During a phase change, like when ice is melting, the temperature actually pauses its climb. It plateaus. While the solid is turning into a liquid, the heat energy you're adding isn't making the substance hotter. Instead, that energy is going to war. It's battling to break those strong attraction forces between the particles. And it's only after those forces are completely overcome that the temperature starts to rise again.
Moving right along to part 2, the historical zoom, covering the development of the atomic model.
Let's trace how this whole microscopic model was built. It's kind of like a scientific relay race spanning thousands of years. It actually kicked off way back around 500 BC when Democritus first floated the idea of atoms. But things didn't get formal until the 18th century, when John Dalton proposed the atom as the solid, indivisible sphere. And from there, the pace of discovery just skyrockets. Thomson finds the electron, Rutherford uncovers the nucleus, Bohr maps out these specific electron shells, and then finally, mid-20th century, Chadwick completes the puzzle by discovering neutrons.
But if we're talking about massive game changers, we have to talk about Ernest Rutherford. Before his experiments, scientists kind of assumed an atom's mass and charge were just spread out evenly, like a plum pudding. Rutherford literally flipped that on its head. He realized that almost the entire mass of an atom is actually concentrated in a super tiny, incredibly dense, positively charged center called the nucleus, with the electrons just sort of orbiting out in the empty space around it.
It's honestly a perfect example of how science is this constantly evolving process. One researcher refines the model of the last until we arrive at the complex structure we use today. Dalton gave us the foundation. Thomson layered in the negative electrons. Rutherford found that dense positive nucleus. Bohr organized the chaos by putting electrons into defined orbital shells, and then Chadwick found the heavy neutral particles, the neutrons, just hanging out in the nucleus right alongside the protons.
Which brings us to part 3, the microscopic engine, diving into atomic structure and ions.
So inside this microscopic engine of the atom, we have a really delicate balancing act. The nucleus is packed with heavy, positively charged protons, and those neutral neutrons we just mentioned. The total count of those particles combined is known as the nucleon number. But it's the proton number alone that actually defines what the element is. In chemistry, we use a standard representation format to easily show this makeup at a glance. And zipping around the outside of that nucleus, the negatively charged electrons. They perfectly balance out the positive charge, but here's the crazy part. They have practically zero mass.
Now, atoms rarely just sit still. Based on their electron arrangement, they are constantly looking to achieve stability. And to get it, they'll transfer those weightless electrons. Take sodium and chlorine, for example. A sodium atom might donate one of its outer electrons to a chlorine atom. Because electrons are negative, losing one turns sodium into a positively charged ion, and gaining one makes chlorine a negatively charged ion. These charged particles, ions, are fundamentally attracted to each other, and that magnetic-like attraction forms the foundation of chemical compounds, like the literal table salt you put on your food. So at the end of the day, all this matter gets classified into two main buckets: elements and compounds. Elements are pure. They are made up of atoms or molecules of just one single type. Compounds are the magnificent mashups, linking different elements together through the sharing or transferring of electrons that we just talked about.
And finally, part 4, real-world power, where we'll look at isotopes.
Okay, to understand this real-world power, we need to talk about isotopes. Sometimes, atoms of the exact same element have different numbers of neutrons, still have the same proton number, so chemically, they act exactly the same, but their mass is different. This variation is actually why elements have a relative atomic mass rather than just a clean whole number on the periodic table. Now, when these specific variations become unstable and exhibit radioactivity, we call them radioisotopes. And let me tell you, that radioactivity is incredibly useful.
This is where chemistry gets super practical. Take a PET CT scanner used in hospitals. These machines use radioisotopes as medical tracers. Doctors inject them into a patient, and because they emit these very low levels of radiation, the scanner can track exactly where they travel in the body. It allows the machine to visualize not just the static anatomy, but the actual real-time metabolism level of the patient's cells. By harnessing specific isotopes like these PET tracers, doctors can pinpoint the exact anatomical location of cancers, or intense inflammation, or deep infections, way before they could ever be found using traditional structural imaging alone. It's a total game changer. And it goes beyond just taking pictures. Another radioisotope, cobalt-60, is actually used in advanced medical treatments to aggressively target and destroy cancer cells. It is just wild to think about, right? Understanding something as mind-bogglingly tiny as a neutron, a particle we didn't even know existed 100 years ago, now allows us to literally heal the human body today. We've gone from questioning why a rainbow isn't matter to tracking radioactive isotopes inside a living human cell. It definitely leaves you wondering, as our tools get sharper and our understanding of this stuff grows deeper, what other world-changing secrets are still hiding down there in the microscopic world? Thank you so much for joining me on this explainer. Keep asking questions and definitely keep exploring. Catch you next time.
All right. I hope your understanding now increased by another few steps. Right, should be at the level of 8. 8 is the highest steps. That means out of 10 questions, you need to have a minimum 8 correct. Right, so let's move on to the next one.
Welcome to today's deep dive.
Okay, as usual, I'm going to highlight the lady and the gentleman who is discussing on this chapter, whether it's in drawer 1, drawer 2, drawer 3, or drawer 4. Let's start now.
You know, you look at a wooden table and your brain just naturally accepts it as solid.
Right, it just feels solid.
Yeah, but when you dive into the advanced chemistry notes we're unpacking today, that solid wood dissolves into this microscopic landscape that is honestly just fundamentally counterintuitive.
We are taking you on a journey today from the tangible, everyday macroscopic world, down into the invisible, fundamental building blocks of reality.
And to understand that machinery, we kind of have to look at matter. Like, just define it simply. It's anything with mass that occupies space.
Exactly. And we grow up learning the basics, right? Solid, liquid, and gas.
Yeah, and we know that adding heat just cranks up the kinetic energy. It's like increasing the tempo of music at a dance.
That's a great analogy, actually.
Right, like as the heat goes up, the particles break out of their rigid, orderly lines from a solid state, and they just start moving frantically apart into a gas, like ice cream melting or water vapor condensing on cold glass.
But the notes highlight this major blind spot in our Earth-centric view, because the most abundant state of matter in the universe isn't solid, liquid, or gas.
Wait, really? Then what is it?
It's plasma. I mean, ionized gas, you rarely interact with it here on Earth, but if you look up at night, the stars themselves are just massive, turbulent spheres of plasma.
Oh, wow.
Yeah.
So we have these interacting particles of matter, whether in a star or, a coffee table. And for the longest time, scientists like John Dalton assumed those particles were the absolute end of the line.
Yeah, they thought they were just indestructible little billiard balls.
Right. But cracking those particles open is, well, it's a masterclass in challenging assumptions.
Totally. J.J. Thomson peeled off the first layer by discovering negatively charged electrons, which immediately meant there had to be something positively charged hidden inside, to balance the atom out.
Which brings in Ernest Rutherford. He fired positively charged alpha particles at a sheet of gold foil, expecting them to just punch right through.
But they didn't. Some bounced straight back.
Yeah, it was like firing a cannonball at tissue paper and having it ricochet. That proved the existence of an incredibly dense, positively charged core, the proton nucleus.
And then Niels Bohr later realized the electrons actually orbit around that core in very specific shapes.
Wait, to back to this model for a second. It's mind-boggling that we kept finding smaller Russian nesting dolls inside the atom. But if Rutherford found a dense core packed entirely with positively charged protons, why doesn't the atom just blow itself apart?
It's a fair question. Basic electromagnetism tells us positive repels positive.
Exactly, that nucleus should violently explode.
Well, that exact paradox is what made James' discovery of the neutron so vital.
Oh, because neutrons have no charge, right.
Right. They carry no electrical charge, but they sit packed in the nucleus alongside the protons. and they help generate the strong nuclear force which overpowers that electromagnetic repulsion.
So it binds the whole volatile package together.
Ex-
Let's zoom in on that final nesting doll model then. You've got the proton number acting as the atom's ID card. Carbon is carbon because it has 6 protons. Full stop.
And then the nucleon number on top tells you the total mass. So the protons plus those crucial binding neutrons.
Right. And atoms become neutral or they become charged ions by gaining or losing electrons. That's the standard representation.
And the division of labor there is really elegant because the protons in the nucleus dictate the element's identity, but the electrons orbiting on the outer edges, they dictate its personality.
What do you mean by personality?
Well, whether an atom gains or loses electrons entirely dictates how it bonds and reacts chemically with the rest of the world.
Oh, I see. Protons are identity, electrons are personality. But what happens if the atomic ID card stays the same, but the atom packs on extra weight, like extra neutrons?
We call those isotopes. They're atoms of the same element, same proton number, but different nucleon numbers.
Let me ask a clarifying question for the listener. Does having extra neutrons change how an isotope behaves in everyday chemical reactions? Or does it just make it heavier?
It primarily just makes it heavier. Because elements in nature are usually a mix of these, chemists calculate a relative atomic mass based on natural abundance. But those extra neutrons often make the nucleus physically unstable, resulting in radioactivity.
And rather than just being a hazard, the notes show how we use that radioactivity as a tool, like cobalt-60 in PET-CT scans.
Yeah, the mechanism is fascinating. A patient ingests a compound with a radioactive tracer. Because the isotope's chemical personality hasn't changed, the body treats it like normal nutrients.
So it pulls it into highly active cells, like cancer cells.
Exactly. Once inside, the unstable nucleus decays and essentially fires off a microscopic radioactive flare.
Yeah.
The scanner detects those flares to map rapid cellular metabolism.
That is just wild. We are leveraging the instability of a few extra neutrons to light up disease on a medical scan. We've scaled all the way from a melting scoop of ice cream down to radioactive isotopes saving lives.
It is a spectacular chain of mechanisms hidden inside literally everything around us.
Which brings us right back to that solid wooden table. We know every atom in it is overwhelmingly just empty space between that dense nucleus and the electron shells. So we will leave you with this final idea to ponder.
It's here.
If you and the table are both made of 99.99% empty space, why does anything you touch actually feel solid?
All right.
Welcome to today's...
I think that is going to help you to understand this chapter way more. Let's do step 10. I'll have the notes next to you, and I'll have this. Is it? Yeah. Ask me 10 MCQ and list the drawer name. 2 MCQ at a time. No answer. All right, let's do the same drill. This one is your reference. You can use your reference if you have the picture drawn or screenshots. Now let's start. Which statement is best defined matter? A, B, C, or D? Anything that can be seen, anything that has mass and occupies space, anything that contains atom only, anything that is solid. Which change of state occurs when a gas changes directly into solid? Okay. Let's start. Tell me, typing your answer. What is 1? Okay. Doesn't matter if it is wrong. Okay. Our objective here is not to test if you are smarter than the other students or not. Objective here is to know which level you are in yourself, and then which part that you maybe miss in certain drawers. Okay, I have Eric B. What about the rest? 2A. Anyone disagree? Anyone? Why is it only Eric is typing? What about Jing Sam? What about Xuan Xuan? What about Xingling? And Jaden? B and D. Okay, so we have two answers here. Okay, let's wait for the rest. Then we'll see which answer we want to go with, A or D. Xuan Xuan, Jaden. I saw Xingling was typing just now. Hurry up, hurry up. Jaden, Xingling, Xuan Xuan, are you with us? Okay, we have 2D also. Eric, do you want to refer to the keynotes here? Step 2, drawer 1, and try to find the answer. Jaden is typing. What about Xingling? Xingling, what is your answer? You cannot see the question? What do you see? Do you see anything? Okay, let me share again. Stop sharing and share again. Okay, something wrong with Xingling's connections. Okay, Xingling, you are back. Do you see the, okay, Jaden, now do you see the questions? Do you see the questions? Question 1 and question 2? Or what do you see?
I can't see anything.
You cannot see?
Yeah,
So what do you see? You see black screen or white screen or what?
that's a white screen. I know it's just a white screen.
Just a white screen.
Yeah.
Just a white screen. Okay, let me check again. What about now? Just now the video you can see, right?
No, I want to see the keynote.
You cannot see the video also? So throughout the class, you did not see anything? There's no video, there's no screen.
No, I saw the screen, like all the keynotes and stuff like that. I didn't see the video.
You did not see the video.
Yeah.
Okay, then you should message me when you have this problem. But now, do you see anything?
No.
Still white screen?
Yeah.
Okay, can you log off and log in again? Xingling, can you see the question? I'm sure Eric, Xuan Xuan, and Jing Sam, they are able to see the questions because I got their answers. It was lagging. Okay. Yes. So, okay, Jaden is back. Xingling, you can try to answer the questions 1 and 2. Okay, Jaden, we can see you. If you want to turn off your video to save your bandwidth of your internet. Okay, can you see the question now, Jaden?
Oh, yes.
Excellent, excellent. Okay, So for 1 and 2, we will continue. Jaden, you can participate in 3 and 4. Right. So Eric is D, right? Okay, yes. So the answer is B and D. Now let's do drawer 2, question 3 and question 4. Number 3. Which scientist first proposed the matter is made up of tiny indivisible particle called atom? Okay, the answer is in the keynotes. And also if you refresh on the story, the answer is also there. Okay, C and B. All right, we have Xingling and Eric answered. Jaden, you're trying to say something? Okay, C and B. Jing also C and B. Jaden, are you with us? Is everything fine from your side? If yes, can you tell us your answer? Is it also C and B? Or you have different answers? Jaden is typing, so I'm waiting. Okay, good. Yeah. Unfortunately, you did not complete the step 8 and step 7, step 9, which is the video and also the podcast. But in case you need to watch it again, I'm gonna put this class into the YouTube video or YouTube channel. Right. So why is it still drawer 2? Okay, it's okay. Let's see. So drawer 2, you have 5 and 6 questions. Which scientist proposed that electron move around the nucleus in a specific shell? Which subatomic particle was discovered by James Chadwick? Anyone wants a guess? Anyone guess? Or not guess, provide your answers. C and D. What about the rest? We only have one answer. C, okay, same CC. Also C. What about 6? D. The rest? Okay, let's try. Okay, so C and D, that's correct. Go for 7 and 8. That is drawer 3, atomic structure. Jaden, I need your answer. Right, 7 and 8. Everyone, especially Jaden. Jaden missed 1 and 2 and also 5 and 6. An atom has 17 protons and 18 neutrons. Okay, let's scroll up. Okay. What is the nucleon number? What is nucleon number? C and D. Nucleon number is proton plus neutron. Number 8. Which statement about a neutral atom is correct? All right. So we have Xingling lead the way. C and D. What about the rest? Shunshun also C and D. Jaden, yes. Good to see you typing. C and D as well. Jingsam and Eric. Mr. Eric, are you with us? Okay, everyone is C and D. Eric got C. And I think he's going to answer D, yes. All right, isotope, drawer 4. Apa itu isotope? What is isotope? Sorry, I'm speaking in Malay. Question 9. Which statement correctly describes isotope? What is isotope? Which isotope is commonly used to determine the age of a fossil, an ancient artifact? Oh, I think it's... Okay, the answer is all inside the keynotes. Let's see who gets the first answer. Yeah, Xingling. Xingling got it. Let's see whether it's correct. Okay, Chen Chen got C for 10. Xingling is still thinking about 10. Ting Sam got B and C also. Eric got B. Jaden is still thinking. Xingling got C. Eric got C. Jaden is now typing. Hurry up, Jaden. B and C. Okay, everyone got B and C. I think it's correct. Yeah, me too. Excellent. Now, that is about it. I think everyone got very high marks. Okay, let me tell you something, which I told Xingling this morning. I'll tell you again. I told everyone who attended my class last week. I think Jaden was not here. Only a few. Jingsong was not here. Okay, now. Give me 5 minutes to explain this. Okay. Now, we have scenarios. Okay. We have, let's take Jaden. Jaden 1. Let's take Jaden as the main example. Jaden 2 and Jaden 3. Who is Jaden 1? Jaden 1 is somebody who have no knowledge about a topic. For this case, let's take this atomic structure. Right, 2 hours ago, Jaden 1 doesn't have any idea about what is atomic structure at all. This chapter, matter, atomic structure, atomic model, isotope, 0. And Jaden 1 wants to become level 9, right? Which is what Jaden is right now, including Jingsam, Isa, Eric, and Shen Shen. You're all now in level 9. How do you do it? How? Right. You do it with this 2 hours class. Right. And now, in case the chapter that we have learned for the past few months, one of the chapters you feel that it is important for you to become level 9, but apparently you are at level 1 because you've forgotten, right? Whichever chapter it is, could be cell, could be electromagnetism, could be chemical separations. Okay, there is many chapters that we went through. And how do you able to help yourself now from level 1 to level 9? Okay, watch YouTube. Watch what YouTube? Watch my YouTube channel, which I uploaded everything, all the videos that is that we have recorded. So let's take example, right? There are SPM. Okay, let's take last week. I think last week we went through this one, measurement. I think so, right? Okay, I can't remember. Oh no, okay, 2 weeks ago, we studied Form 4, Chapter 1 measurement. Right, Form 4, Chapter 1 measurement. And take example that this Chapter 1 measurement, you have zero knowledge now, you've forgotten. Okay, yeah, you've forgotten. And you need to remember, you need to improve your level 1 to level 9. Right. And if you have 1 hour and 30 minutes, you can just watch this video again and you will be able to reach to level 9. And I'm sure you're very confident that you're going to go to level 9 because all this while, all the classes, you are able to understand and get a very high score on your MCQ, and that is level 9, right? So that is what's the YouTube on this channel. And then how do you watch the YouTube? Which YouTube is important for you? This is the titles, all right? Which title you want, then you just will watch accordingly. So Jaden number 2. Jaden number 2 is level 9, which is Jaden today, or Xingling, or Jingsam, or Eric, or Shun. Xingling left is fine. Okay, because Xingling knows about this. So now you want to maintain at level 9. How? How do you maintain at level 9? You need to do revision. Right. You remember this revision is the 10 to 15 minutes revisions that I told you. And this revision is this one. Right. I'll take one example. I'll just take any chapter. Right. So this revision is, for example, this is a chemistry chapter. And you have step 1, you have to remember the main story. So every chapter we have main story. Step 2, you have to remember the drawer name. Every chapter we have drawer names. Step 3, you have to remember the story. And then you'll be able to explain it to somebody who did not attend our class. Right. Of course, if you tell him about Prince Elton, very good papa, he will not understand what you're talking about, but you have to explain to him what is inside the periodic table for this drawer. Right. Then you are able to draw this drawer out. Okay, draw this drawer out. Then that is completing the step 1 and step 10, step 1 and step 4, and that will usually take about 10 to 15 minutes. And that is entire chapter, right? So let's say you have 10 chapters and you only need 10 days. If you do one chapter one day, if you do two chapters one day, then it's only 5 days. It's really depending on you, right? And that is if you want to maintain it at level 9. Now, Jaden 3. Jaden 3 is the Jaden who is going for SPM or IGCSE, right? So you need to be exam ready, right? How to be exam ready? First, you need to continue to be level 9, and you need to start to do past year question, exam question, right? So that you are familiarized yourself with the exam questions. So when you do that, then that means that you're exam ready. So imagine tomorrow you're going for the exam. That means that you need to at least be in level 9 and also be exam ready. Exam ready, that means that you have to do your exam questions, right? If you do not do exam questions and you're only at level 9, then you're not exam ready. You're not ready for IGCSE or even your final exam or SPM, right? So this two I've already taught you, and I told you exactly how to do it. If you have 2 hours, then you can go from level 1 to level 9. And if you have 10 to 15 minutes, then you can maintain your level 9 as long as you want to maintain. But to be exam ready, you need to do this, right? You need to do this. So there are the 3 stages of Jaden, or 3 stages of Eric, or 3 stages of Jingsam or Xuan that you need. It's really depending on which level or which stage you want to be in, right? And there are ways to help you to be in that stage if you want to be that in that stage, right? For Jingsam, next year you're going for exam, SPM. So you have to be in Jingsam 3 before your SPM, right? So now, if you're at this 2 level, you're fine, right? But this 2 level is to help you to be able to answer the exam, past year exam questions before you sit for exams, right? For Eric, Jaden, and Shen, you still have 1 more year, more than Jingsam. But the earlier that you prepare yourself, the better it is. Okay, so that's it. That's the last part. Thank you very much. That's all. Hope we'll see you next week for another chapter. Thank you. Bye bye.
Bye-bye.
Bye bye.